So hi guys, in this video I'm going to show you the circuitry of the different logic gates, specifically the NOT logic gate, the OR logic gate, and the AND logic gate in the breadboard. Then I will also show you the truth table of each logic gate. So let's begin. So as you can see in the video, there are the three different logic gates. So let's start off with the NOT logic gate. So in the NOT logic gate, we use an integrated circuit number 7404 or IC 7404, in which we use to perform the NOT logic gate. Each pin of the IC has its own role. So here is the pin diagram of the IC 7404. The yellow wire above the IC represents the VCC or voltage common collector, which collects the positive current from the power source. The yellow wire below the IC represents the ground, which collects the negative current from the power source. Then, the red wire represents our input, in which the wire is connected from the pin 3 of the IC to the switch 1. To connect the other side of the switch, I use the blue wire to connect it from switch 1 to the negative terminal. And for the output, we use a resistor and connect it from the pin 4 of the IC, to the area where it is free from any confliction. Moreover, resistor limits or controls the current flow so that the LED will not be broken easily. Then, we use LED light to show how the NOT logic gate works. So the positive part of the LED is connected to the other end of the resistor, while the negative part of the LED is connected directly to the negative terminal. So in the OR logic gate, we use an integrated circuit number 7432 or IC 7432, in which we use to perform the OR logic gate. So here is the pin diagram of the IC 7432. As usual, the yellow wire above the IC represents the VCC or voltage common collector, which collects the positive current from the power source, while the yellow wire below the IC represents the ground, which collects the negative current from the power source. This time, there are two inputs, so the red wires represents both our inputs, in which the wire of input 1 is connected from the pin 1 of the IC to the switch 2. And to connect the other side of the switch, I use the blue wire to connect it from switch 2 to the negative terminal. And for input 2, I connect it from the pin 2 of the IC to the switch 3. And as for the blue wire of switch 3, just do exactly the same as the blue wire in input 1. And for the output, we use a resistor and connect it from the pin 3 of the IC to the area where it is free from any confliction. We also use LED light to show how the OR logic gate works and place it the way how we place the LED from the previous logic gate. So in the AND logic gate, we use an integrated circuit number 7408 or IC 7408, in which we use to perform the AND logic gate. So here is the pin diagram of the IC 7408. So as usual, the yellow wire above the IC collects the positive current from the power source, while the yellow wire below the IC collects the negative current from the power source. So this logic gate also uses two inputs. So the red wires represent both our inputs, in which the wire of input 1 is connected from the pin 4 of the IC to the switch 4. Then to connect the other side of the switch, I use the blue wire to connect it from the switch 4 to the negative terminal. Then as for the input 2, I connect it from the pin 5 of the IC to the switch 5. Then as for the blue wire of switch 5, just do exactly the same as the blue wire in input 1. Then for the output, we use a black wire to connect it from the pin 6 of the IC to the area where it is free from any constriction. Then we use LED light to show how the AND logic gate works, and place the positive side of the LED just below the other end of the black wire, and the negative side of the LED to any open area of the breadboard. Then we use a resistor to connect it from the negative side of the LED to the negative terminal. So that is all for the circuitry of each logic gate. So next is I'm going to perform each of the truth table of the different logic gates. So first, we'll take our battery, then connect its positive wire to the positive terminal of the breadboard, while the negative wire connects to the negative terminal of the breadboard. Take note that all of our switches is turned off. So as you can see, there is already an output in the NOT logic gate. So that's because the truth table of the NOT logic gate is that if the input is 0 or turned off, then there will be an output. If the input 1 is turned on, then there will be no output. As for the OR logic gate, here is the truth table. If the input 1 is 1 or on, while the input 2 is 0 or off, then it will have an output. If the input 1 is 0 or off, while the input 2 is 1 or on, then it will have an output. If both input 1 and 2 are 1 or on, then it will also have an output. If both input 1 and 2 are 0 or turned off, then it will not have an output. Hence, we can say that in OR logic gate, there will be an output if one of the inputs or both of the inputs is true, then the output will also be true. And as for the AND logic gate, here is the truth table. So if both input 1 and 2 are 0 or turned off, then it will not have an output. If the input 1 is 1 or turned on, while the input 2 is 0, then it will not have an output. If the input 1 is 0 or turned off, while the input 2 is 1 or turned on, then it will also not have an output. But if both 1 and 2 are 1 or turned on, then that's the time that we will have an output. Hence, we can say that in AND logic gate, there will be an output if and only if both of the inputs are true, then the output will also be true. Otherwise, it's false. So that's all for my video. I hope you learned something, and Thank you for listening and watching. Bye.